Hello, my name is Rich Howard, owner of Architectural Builder Supply, and this video is to bring you a closer look at the Master Ring cylinder. The Master Ring cylinder by Corbin, or PF Corbin. Although it was manufactured by other people, it is currently only manufactured by Corbin Russwin, but it was PF Corbin who brought it into the mainstream of commercial builders hardware. And again, although other people certainly had a two shear line cylinder, which is what the Master Ring is, Corbin is the name by which I think it's utterly recognizable with. This video will serve as a companion to this article that I've written about Master Ring, and let's start with a introduction. The Master Ring cylinder concept, a cylinder that has two shear lines, both capable of operating the lock set, most recognizable by PF Corbin, is unique in the world of commercial builders hardware, and yet there is relatively little information that is actually known about the cylinder, in the sense of I don't believe you're just going to accidentally fall into information about Master Ring. You have to seek it out. It does exist, but you do have to seek it out. And it's remarkable, given the fact that the cylinder at this time has existed for 130 years. And was patented just 3 decades after the patenting of the modern pin tumbler cylinder by Linus Yale Jr. The modern pin tumbler cylinder was certainly based on the Egyptian tumbler design lock from 4,000 years ago. But the cylinder that we all, quite frankly, take for granted and use probably every single day is a mid-19th century invention by Linus Yale Jr., and the Master Ring is founded on that. So it's a cylinder platform that's very common and used, as I said earlier, on a daily basis. But having it patented just 3 decades after the original modern pin tumbler cylinder, it is kind of amazing that it has existed for all of these years, and it'll probably be a century and a half before Corbin Russwin actually sunsets the product. Anyway, I don't have any knowledge about that, about them ever retiring it, but it won't be soon. It's eventual, but it won't be soon. I've spent the last 30 years in the door and hardware industry, and like most of you, I was combinating locks before I had a driver's license. However, my experience in the world of hardware, doors, frames, and hardware, exposed me to the Master Ring in no measurable way. I think I bumped into a customer coming in to our shop in the early 90s with one, and it's as if I had, discovered life outside of our solar system. I didn't know what it was. And fast forward to my pursuit of a CRL designation, Certified Registered Locksmith with ALOA. Decided to do a deep dive into the Master Ring platform, the technology, because once you understand some of the math behind how cylinders work and how changes or change keys or level 2, 3, and beyond systems are created, it's incredibly fascinating, the Master Ring. The Master Ring was originally touted as a platform onto which you would be able to have an unlimited number of change keys, different keys that can operate your cylinder. Unlimited. Now, we certainly know that that number is not unlimited because we can express the math by which it is determined to be quite finite. When you have two shear lines, you substantially increase the amount of potential change keys or differs possible within a system. One might ask, why study the Master Ring cylinder? Because they're rare in certain circles. I would imagine that they're not in others. If you're in the right environment, for instance, the Empire State Building was built 1932, 1933. That was all Master Ring cylinders. So if you're a New York City locksmith, in the mid-20th century, yeah, you're bumping in the Master Ring all the time, I would think. But the reason to study it is because of how interesting a platform it is and how those unlimited changes can be approached because or as a result of how it's built. as I was studying for the CRL exam, I was reacquainted with the Master Ring concept, and I did, again, decide to study it. And what I found most thought-provoking and unique is how the standard rules of pinning cylinders are basically disregarded. So everything you've ever learned about pinning pin tumbler locks, especially in a total position progression environment, you can do away with almost all of that because it doesn't apply to what we're working on. The Master Ring cylinder does certainly have its shortcomings in the world we now live in, because every manufacturer can provide high security systems, high security keys, UL 437 compliance, competitor keys. You want to do, Sargent and Yale locks, or Corbin and Russwin and Schlage locks, or your Schlage keying system and Best locks. It can be done. The Master Ring is not portable like that at all. It is exclusively Corbin Russwin that you're going to be working with if you're doing Master Ring. So it doesn't compete well in the modern modular sort of environment that we live in. But it's certainly still very much out there in terms of installed in places. However, in spite of this, the Master Ring has inherent advantages. And are worthy of study. Other than the modern pin tumbler cylinder, what other variant on that cylinder type or on a modern pin tumbler is something still available after 130 years of its initial patenting? What else can you get that's 130 years old that can still be ordered? The Master Ring is, I think, the only one of a variant of the modern pin tumbler cylinder. Now, as we move further into the discussion, we can study the principle of its design. And I have some different examples of the cylinder here. I have some old rim cylinders. These are just very old rim cylinders. I'm not even sure of the keyway. This could be a 97 keyway. That could potentially make this incredibly old. Another old rim cylinder that we see here. Some modern versions of it as well, and I have a rim cylinder here, a modern, brand new rim cylinder, Master Ring, and it expresses very eloquently how this cylinder type is indeed quite elegant. So what I have here is my key. This happens to be a H-Class System 70 by Corbin Russwin. If that doesn't mean anything to you right now, don't worry. It will later in this video. And we have a cylinder plug that we can tell because our C-clip is holding the tailpiece on and is the item that is projecting out of the back of this cylinder. There's a piece of plastic on there. Thought there was something funny. So literally, this part right here, that's the cylinder plug. Okay. Well, there's a ring that's around it, and guess what we call that? We literally call it the Master Ring. It's the ring sleeve. And when I turn my key, my ring sleeve does not rotate at all. Okay. But I can certainly make that ring sleeve rotate. And we're going to express how it is that works. So the design is indeed simple and elegant. The only thing that you have to be aware of is, I would imagine it has struck you that this is a little bit larger than standard, and we're going to talk about the size as we move through through our article here. The design is indeed simple and elegant. The design of this cylinder serves to maximize the potential biddings available in a cylinder. Its inherent, the genesis on which this cylinder was concocted, devised, detailed, patent applied for, and patent granted was the elimination of incidental master keys. That's why it was put together. Not unlike a Yale bicentric cylinder. If you're familiar with Yale's bicentric, it's literally two cylinder plugs in a mortise cylinder or in a padlock. I've seen them in padlocks. And the concept is when you don't have incidental keys potentially existing in your system, you have a much more secure system. We'll get to incidental keys in a bit. They're also known as ghost keys, by the way. The cylinder is, from what I understand, commonly understood as more time-consuming and resistant to picking, all the while simultaneously not eroding the security of the cylinder whatsoever, eliminating incidentals, more difficult to pick, a solid concept. The Master Ring is an 1.5-inch diameter grade 1 cylinder, meeting the requirements of ANSI BHMA A156.5 standards. Features components capable of rotating independently of each other, creating two shear lines, and that's the plug and the sleeve that surrounds it, and all of that fits into the housing itself. The lower shear line is called the plug shear line, and the upper shear line is called the ring shear line. These two shear lines are made possible by the Master Ring sleeve, which surrounds the cylinder plug. The Master Ring sleeve has a definite thickness and is taken directly into account when pinning the cylinder to solve the ring shear line. The plug shear line is created by the area at the top of the plug and the bottom of the ring shear line. The second shear line is created by the area between the top of the Master Ring sleeve and the bottom of the cylinder shell. The Master Ring sleeve fits inside of the cylinder shell. The cylinder plug fits inside of the Master Ring sleeve. That design allows a separation of key levels, and that's the moral of this story, the segregation, the separation of key levels, which are to be pinned separately, again, very much like the Yale bicentric cylinder. The Yale cylinder was specifically intended to isolate master key biddings from change keys and prevent key interchange. The Master Ring cylinder is the same in that it was devised to accomplish the same task, but it's different in that both shear lines are within a single cylinder, and is the tenet of the Master Ring cylinder technology. I believe the Master Ring is superior, as pin tumblers that satisfy the ring shear line are unavailable for visual review and unlikely for someone to impression a key at the ring shear line. Decoding is hampered when direct access is not available. What that means is, when I look into the broaching of the cylinder plug, I can see the bottom pins that are there, but the pins that exist above that to satisfy potentially my ring shear line, I cannot visually inspect those. I can't see them. Change keys are to be keyed exclusively at the plug shear line. That hopefully is now obvious. The theoretical master key or TMK, and any master pins are pinned exclusively at the ring shear line. Cross or maison keying. Maison is the French word for house. It means, when you have a front door of a home and you've got, different keys that operate that cylinder alone, your key will go into the front door of the house, will allow you then to access other parts on the inside. But there's likely very not a individual key that works that exterior. So you can certainly maison key them as well. That would erode the cylinder integrity. It would be against the grain, so to speak, of what we're talking about. So cross or maison keying is known to be done at the plug shear line, although it does erode the security of the cylinder, demoting it to no better than single shear line cylinder. It's frowned upon in Master Ring as much as it is frowned upon in single shear line cylinders. And the design brings the creation of incidental keys at the plug shear line to zero because you're only pinning the change keys at the plug shear line. This means you are not introducing no additional pins other than the change key bottom pins at the plug shear line. The pins used to complete the combinating of each chamber, the build-up pin, possibly master pins, and the top pin will disallow the ring shear line from rotating as the cylinder plug rotates, as well as disallowing the plug shear line from rotating independently while the master ring shear line is solved. So let's take a break and look at on screen this concept of two shear lines and the theory or the concept of incidental master keys as well. Okay, so we have our cylinder plug. Okay, it has its chambers. let's just say 6. You can do 7-pin. You can do 5-pin as well. 7-pin and 5-pin are available with limitations. The 6-pin is pretty common. So when you pin your cylinder, you're going to pin your change key right to this shear line. But what exists in here, okay, is going to be, what exists over this is going to be your ring sleeve. So it's basically a sleeve that the plug fits into. Well, that all continues up. Okay? And that is indeed where your second shear line is. So now we've got shear line 1, and when we draw in the rest of the cylinder, now let's do this. Pretty poor. I do apologize. I am no artist. Okay, we've got, let's just say this is a mortise cylinder. Okay, got our threads out here. Those holes continue all the way up, as you would have guessed. And it's between the cylinder housing and the master ring sleeve where our second shear line is created. Now, pinning down here is just like pinning anything that you've ever pinned. Your change key goes in, your bottom pins go in, and you're right as rain. Then you'll use your system of build-up pins and master pins to satisfy this ring shear line. So the point is this. Change keys operate here. All of your masters and your TMK will operate here. So what that does is it gets my master key and TMK information away from the visible area. That also allows the concept of the additional changes to be occurred because I'm treating this in my mind as 2 separate locks. And we're going to discover how that is considered that way by means of the key bitting array, or the key bitting arrays that we will create. But that's what that looks like. Okay. Now, incidental keys. If I said to you that we have, if we have a 5-pin cylinder, and our master key is it's a 2-step 5-pin cylinder. Let's say it's a 2-step 6-pin cylinder. There's my TMK. Okay, and you probably know from total position progression, we're going to build a KBA here, and I'm only going to have one change key. And let's just say that that change key is 6, 1, 3, 7, 4, 5. Okay. First question becomes, how many keys work this cylinder? If you run this master key and this change key, well, the common answer is 2. 2 keys work that cylinder, and that's certainly not incorrect, but there's a better answer, and that better answer is 64 keys work that cylinder. Or said another way, 62 keys in addition to the 2 that you intended to work will operate that cylinder. Those 62 are called incidental keys or phantom keys or ghost keys. And just to quickly illustrate that, you know everything 345, 321, that key is going to work. 613, 745 is going to work. But what if I cut a key that was 3, 4, 5, 3, 2, 5? Wouldn't that work? Sure, it would work. What if I cut a key that would be 3, 4, 5, 3, 4, 1? Wouldn't that work? Yep, it would certainly work. I can continue to do that until I hit a total of 64 keys, including these two. It's also expressed as 2 to the 6th power. So 2 to the 6th. And that's just a simple mathematical way to easily figure out the number. I have 2 cut possibilities in 6 chambers. So it's 2 cut possibilities in 6 chambers. If this was a 5-pin cylinder, it would be 2 to the 5th. And that would equal 32. Okay? So the fact that we are segregating or separating our change keys from our master keys, you can see that we have not removed the possibility of incidental ghost or phantom keys. We've utterly eliminated it. They don't exist. Now that's super beneficial. Okay. Now, the next thing to do is to take a closer look at the physical pieces of our cylinder, because I've been doing a lot of talking about plugs and rings and housings and whatnot. Let's take a cylinder apart. Let's do that now on camera. Okay, so what we have here is going to be a rim cylinder. Okay, and because this is master ring, that means that we're dealing with 0.552 cylinder plug diameter. So our typical, effective plug diameter, plug follower, 0.500 is not going to work. This is Corbin Russwin, so we've got to use a 0.552. There's also a 0.509 that's available. There are certainly 509 master ring cylinder plugs that exist. Let's remove that C-clip. And by the way, this is the PK1070 pinning kit. This kit will have everything you need in it to pin master ring. Okay. Let me get a better look at that. There's your cylinder plug. There's our master ring. This is a Z-Class System 70 H4 keyway. Not that that really matters. So I turn that. You can see just that plug turn. Okay. So I'm going to get my 552 plug follower. We're going to remove that. The master ring sleeve is going to stay in place naturally. Okay. So what do I have? I've got this pinned to the ring shear line. Pardon me, this is pinned to the plug shear line. That's all it is. Any chain, this is just a blank. This is obitted. Any blank, any key that you insert in here and pin it accordingly, that's all you're doing. You're pinning that accordingly. So that's our plug. Now we can see our ring shear line. We can see our ring a lot better. So now what I need to do is I need to drop those top pins. There's the first one right there that exist. Okay. Let all of the driver pins or top pins and the springs come out. This is top loaded, by the way. And I'm going to do that now. I'm just going to cover that. Okay, if you were counting, that was 6. If you even heard that. Okay, so all my pins and my springs are captured in my plug follower. We don't want to lose those. Those are going to be reused. Now, okay, a couple of springs did not come out. A pinning tray is a great idea. I don't have mine here with me. I'm going to make sure that they're all out, and they are. And at that point, we are certainly going to reveal the master ring sleeve. Okay. So, our first shear line is created by the intersection of these two pieces. Our second shear line is created by the intersection of these two pieces. That ring shear line, that master ring, the ring itself has a definite thickness. It is a definite thickness based on the plug diameter, 509 or 552. You take in the plug thickness directly into account when you're pinning the cylinder. But now we have done an autopsy on the parts. We pulled everything apart and we can see very clearly how it all works. Okay. So the bottom line is this, just to kind of cut to the chase a little bit. If I had a change key that was cut to anything, I'm going to pin it to my plug. Then let's say that I had a cut key that was cut exactly to the same change key biddings, adding for the thickness of the sleeve, adding that build-up pin, then I would have a key that would operate the ring shear line as well. That key would actually never exist because you would actually operate both plugs. But just to quickly illustrate the concept without getting into the math of how master ring cylinders are pinned, that's what we're talking about. Okay, let's continue on with our article. Okay, now as we move through the article that we're going over here, the design of the master ring also permits a significant increase in differs and keeps the bidding of the master keys and the TMK from being discovered via the Dayton method. Why is it that you can increase differs? Well, it's exactly because we treat those two shear lines as separate entities. They're mutually exclusive in that regard. And when we talk about key bidding arrays shortly, we're going to kind of expose why that's the case. Now, the Dayton method doesn't work on a master ring cylinder because, without going into all of the details of the Dayton method, of which I'm not an expert anyway, basically, if you had a single shear line cylinder and you had a known good working change key, that change key worked the cylinder, and you knew or you expected it to be master keyed. If you had knowledge of the keying system, the structure, the manufacturer's keying structure, you would be able to progress each chamber one at a time until you inserted that key, and while you altered a cut in one of the chambers, it started to work. You recorded that number. You could progress through all 5, 6, or 7 chambers until you were able to discover the alternative bidding that is beyond what you are using in that change key. You are basically exposing the incidental keys that would work. However, in this case, what you're exposing is likely what a master key is. Now, that won't work on a master ring because when you insert that known good change key, if you start to progress that until another bidding would satisfy, the problem is you would never realize it because there are no master wafers at the plug shear line. All you're doing is changing the cuts, let's say in the first chamber, and you're moving your pin stack up and down. And you might be able to theoretically satisfy the ring shear line, but now your plug shear line isn't satisfied. So you cannot expose master keys or the TMK with master ring as a result of the Dayton method at all. The Dayton method is not difficult to understand and exposes the importance of having restricted key blanks in your system. If you've got a cylinder that's master keyed and you have access to the blank and you have access to the knowledge of the system, it is theoretically possible that you can create a key other than that known good change key. Now, if you've got a master key, or a TMK, well, you're not trying to, expose any other biddings. You have the all-powerful key, but it's not going to work in master ring. Okay. This design dispenses with the limitations of the single shear line design and safely permits the inclusion of nearly all of the TMK biddings in the change key. That talks about the key bitting array, which we'll go over in a bit. The TMK and master keys are pinned at the ring shear line by use of a simple system of build-up pins when a level 2 system or greater is the specification. To clarify, if there's only a TMK involved along with your change key, which would be level 2, you'll pin your cylinder to the plug shear line. You'll pin your master key to the ring shear line. Okay, and you'll use that system of build-up pins to achieve that. Any master keys will require the addition of master pins, which would be a level 3 system, in addition to the build-up pin to satisfy the master keys at the ring shear line as well. Only when you have a single keyed cylinder would you only have bottom pins and driver pins, and they would naturally be quite long driver pins because of the increased diameter of the cylinder. They're just long driver pins is what they are. Okay, if you're familiar with Corbin Russwin's interchangeable core cylinders, you're familiar with build-up pins. Not only is it similar, it's identical. So that will be an easy stretch for you to get into. Now, Corbin says, as a result of the dual shear line, the master ring permits a 6-pin key to theoretically have the number of changes available that you would see in a 7-pin conventional cylinder. While this is a major oversimplification because we don't know the key class, the system, or the method of progression, total position progression, or RCM, rotating constant method, it does shine a light on Master Ring's inherent capability of giving you a lot more change keys, okay, without doing much different. In the example that will follow of our KBA, it demonstrates a single-step 7-pin cylinder, a single step, that would be System 70 in Corbin Russwin speak, because it showcases the potential size of the pool of available changes in a Master Ring cylinder. The Master Ring design generally does not permit the inclusion of single shear line cylinders once a system is established in a Master Ring environment, as having change key, master keys, and the TMK all pinned at the single shear line would create chaotic key interchange and result in incidental keys that would certainly exist. There could be uses for a single shear line cylinder, like maybe a SKD, a single keyed cylinder in a pharmaceutical closet in a hospital. But generally, when you're going to run Master Ring, you're going to stick with Master Ring. Now, moving on further into our article, we talk about the technology of the cylinder. As stated earlier, the Master Ring is an 1.5-inch diameter cylinder. They also call that a jumbo cylinder, is what it's called. And for comparison's sake, we can talk about different cylinders. And I have 3 of the 4 in my comparison chart here available to review, and let's do so now. Okay, now there are 4 cylinders that I refer to in the article. One is the peanut cylinder, and I don't have a peanut cylinder here. I've seen them online, and I may have seen them in real life. I don't recall. But it's a mortise cylinder that's a 3/4-inch diameter. It's a tiny little mortise cylinder. In my article, there is a link to where you can review what that looks like online. The next cylinder, of course, is our standard 1.15, our good old, trusted, tried and true 1 5/32 of an inch mortise cylinder. That's the baby right there. That's the one that we're always working with, that size. 1.15 is the diameter. Okay, when I put my caliper on it, it's 1.15, 32 threads per inch. Then we get up to our Master Ring. This happens to be a flexible head Master Ring cylinder, flexible head. We'll talk about flexible head in a moment. But this is our jumbo cylinder, our 1.5-inch diameter. Put my caliper on there. It's, depending where I get it placed on the threads, it's 1.509, that sort of stuff. And for comparison, we can hold them up together and get an idea of what that looks like. Okay. It's substantially larger. Well, we can go bigger than that. We can go with the mogul cylinder. Okay. It's certainly a lot bigger than our master ring, and it serves to dwarf our standard cylinder. Okay, the Mogul, and they do have Mogul Master Ring. Mogul Master Ring certainly exist. Two-inch diameter. I believe this is 27 threads per inch. The Master Ring is also 32 threads per inch, ultra fine. My caliper tells me it's 2. It's depending on where it hits the threads. That's a 2-inch diameter cylinder. That's awfully large. Now, the Mogul cylinder is not part of this conversation. I'm just showing it to show you in relationship as to how everything, kind of size-wise relates to each other. Okay. The Mogul cylinder is a cylinder that is used exclusively in detention applications. Why is it so big? That's because everything inside of it is so much larger. That's why. It is built to be substantially larger. The pins, the springs, the plug, the keys, everything. And it's because of the application. It has to be ultra heavy duty. Not a part of the builder's family of material at all, but it is a mortise cylinder, so herein we mention it. And that's why it's included here. Now, back to our article. As stated earlier, this is an 1.5-inch diameter cylinder that we're dealing with, and it is so as to accommodate either a 509 or a 552 plug diameter. Because both existed. And this plug I have here, as I said earlier, this is .552. Now 509 exists. I don't know if any of the examples I have here are 509. This one may be 509. I'd have to take it apart. Certainly mid-century would have been, early 20th century would have been 509. But the cylinder is bigger because the plug is bigger, and you have to account for that ring, that master ring. Okay, this is the master ring sleeve. The outside diameter of this sleeve alone is .833. So that's 13/16 alone, basically. So we have to account for that. Is what I'm driving at. The master ring, the sleeve surrounding the plug, has a definite thickness, which is equal to a 0 buildup pin. We'll get to that when we talk about combinating. The cylinder design is available in scores of Corbin Russwin keyways in both pre-System 70, which was 2-step progression, and System 70 single-step progression. System 70, the year 1970. That's when Corbin went from a 2-step pre-System 70 to a single-step System 70 method of keying. And let's just switch to the screen view, and we will briefly talk about the difference between the two. So the difference between pre-System 70 and System 70 is this. In pre-System 70, you would have had 10 depths in your system. Okay? In System 70, let's say you have 6 depths. The increment on your pre-System 70 may have been something like 0.014. And in your single step, the increment might have been 0.02, it might be 0.028. This might be 0.015, whatever it is. The bottom line is, in a 10-step system, if you had numbers 0 through 9, and over here you have 0 through 6, because the difference between 0 and 1 and 2 and 2 and 3 and 3 and 4 is only 0.014 apart, you can't have change keys that are 1 and then a change key that is 2 in the same chamber. It's not going to work because the increment is too small. But when they converted to a single-step system, you could have a 0 and a 1 next to each other in terms of the same chamber. because now our increment, the distance between a 0 to a 1, from a 1 to a 2, from a 2 to a 3 is now 0.28. And that would permit something very important. Now, here's what's very important. In your 10 depth system, you would have 0, 1, let's just do this, 0 through 9. Let's just say that your master is a 0. What are your possible change keys? 2, 4, 6, and 8. Actually, it would be better to draw it. 0. What are your other cuts available underneath here? Because it's a two-step system. 6 and 8. That's a two-step system. So in your KBA, you have 4 possibilities per chamber. Now let's say that we have a single-step system. I have a 0 in my first chamber, whatever it is. In a single step where it's 0 to 6, my possibilities are okay. Now, the problem will be your max. Let's just say that 0 to 6 doesn't exist because of a max violation, maximum adjacent cut specification. But where before we had 4 possibilities, we now certainly have 5 possibilities. Now, why is that important? Well, as we said earlier, remember our incidental keys that we had 2 possibilities per chamber in a 6-pin environment was 64. Let's do the same math. In a 2-step environment, I've got 4 possibilities in a 6-pin chamber versus 5 possibilities in a 6-pin chamber. So 4 to the 6th power is 4,096 changes. 5 to the 6th power, and this is where the money is, 15,625. So now you can understand why going to a single-step system was huge, was absolutely huge. Okay? This math really comes into play later when we show the key bitting array for Master Ring. Okay? It gets really epic. Let's switch back to the screen view. Now, as we continue on through our article, the Master Ring can be done in either pre-System 70 or System 70. It probably exists mostly in pre-System 70 two-step progression because its heyday was, 100 years ago. As an aside, there is a thorough deconstruction in Robert G. Sivkin's book of Master Ring cylinders in a hotel cylinder environment. This gentleman has written several books. One or two of them, certainly one of them was very responsible for me helping me pass a section of the CRL test when it came to disc wafer locks, wafer tumbler locks. So this is his interchangeable core manual, but it has a chapter on Master Ring, and in it he goes into depth on a hotel function Master Ring cylinder, which does not exist anymore. You can't do a hotel function on a Master Ring. I don't know why they can't. It's easy to make. If you had, you could probably make one yourself, but those cylinders are deconstructed in his book. Now, interestingly, it would be awfully nice to have a hotel cylinder because it would be an opportunity for you to be able to control a lock with an emergency key. You could control rights and privileges over an opening with that special emergency key. But apparently it's not an issue, so Corbin Russwin doesn't offer it. Now, moving on, early on, Corbin included ball bearings in all chambers. They literally placed ball bearings in the plug, and I have a ball bearing here. The diameter of the ball bearing is 0.116, which is the same diameter as the pin as well. Now, the reason that they put the ball bearing in the chambers, they discovered there was a problem. They concocted a beautiful marketing method to address it, recover from the problem, and sell more locks, I imagine. The keys were made of German silver, nickel silver. Nice material to make a key out of. The tumblers were not. They were softer, not working very well with heavy usage. The harder metal would wear out the softer metal. What they decided to do was to get balls placed in each of those chambers so that when the key enters, that ball bearing is literally doing nothing but rotating, okay, allowing that key to move in really nice with almost no friction and no wear and tear directly on the softer alloy of the tumblers. If you find ball bearings, and if you have a Master Ring cylinder and you find ball bearings in all of them, that's a really old cylinder. I think towards the mid-century it was certainly reduced, well, maybe towards the 1930s it was reduced to just the first two chambers, because those are the chambers that are going to get all the use of the key going in and out, right? But as more durable alloy became available for pin tumblers, the problem kind of went away and they discontinued using it altogether. I really should not have taken this long to tell you about the that felt like a commercial, to tell you about the Corbin Russwin cylinder manual. I happen to have a printed copy. I attended a high security cylinder class at Aloha in 2019. Here is a commercial. I very much recommend that you be a member of Aloha. If not for the camaraderie, if not for the networking with people that do the same sort of stuff, if not for access to the coursework, but perhaps for the access that you'll get to your instructors. I had a question on this article during the writing of it, and I was able to tap the shoulder of one of my instructors from Aloha, who was able to, give me the green light, so to speak, on this trouble area. And without Aloha, I wouldn't have the ability to literally tap the shoulder of someone who is, and Aloha 2019 tapped the shoulder of two people who, are mentions in the Hall of Fame of locksmithing. I mean, they get their own section, and for that reason, it's certainly worth it. The annual dues are really inexpensive. The continuing education is all the time. They have a great onboarding program for new locksmiths and their AFL, their Aloha Fundamental Locksmith Approach, a 5-day class currently. I really recommend it. Comparatively, it's dirt cheap to be a member. That's just the bottom line. I've spoken to some people. I say, hey, are you a member of Aloha? No, I don't need any of that stuff. Okay. Okay. I personally find that my future growth, that my ability to grow in my understanding of the subject matter is directly related to my ability to network with experts, true experts in the area. So that's my opinion on it. So those ball bearings ultimately went away when better alloys became available. And if you have a mid-century, there are probably ball bearings in these rim cylinders, would be my guess. Very likely. I don't know that keyway. That could be, like I said earlier, that could be a 97. You won't find them in new obviously new cylinder. You could install them if you wanted to. They do. If you study how a key would hit the ball bearing and the ball bearing could do nothing other than roll, yeah, you can understand how it would serve to reduce wear and tear, I think, against the pin itself. But there obviously isn't a need because you don't see it, is the bottom line. Now moving forward, historically 509 and 552 plug diameters have been available to be ordered, but today only the 552 is available from the factory. Russwin offered a master ring, and when it was under the Russwin banner alone, it was always 552. Sargent had their duplex cylinder, which was a dual shearline cylinder. Folger Adams, Southern Folger, has a mogul size master ring. I don't know if that mogul I have is a master ring. I've not taken it apart. I don't have the spare parts to put it back together. I don't have a pinning kit for that, so I've not immediately dove in and started taking it apart. I will at some point. Master ring cylinders feature 4 different types of pins. You've got bottom pins, build-up pins, master pins, and top pins. Springs, obviously, spring covers. Top loading them is going to be how that's generally done. When I put this back together, I will just load it through the plug, but it's kind of a drag doing that because you have to push the pin down and push your plug follower. But it's only because I've got driver pins to install. I don't have build-up or master or build-up pins to install. Level 1 cylinders will only have bottom pins and driver pins. Level 2 will have bottom pins, build-up pins, and driver pins. Level 3 will have, level 3 and beyond will have bottom pins, build-up pins, master pins, driver pins. The TMKs and all MKs will be pinned by adding those build-up pins and master pins when required to satisfy the ring shear line. There's a similarity between interchangeable core and master ring in that there are 2 shear lines. Interchangeable core has 2 shear lines. The function of the second shear line, however, is what makes them very different. Interchangeable core shear lines, whether it be small format or large format, that second shear line allows you to pull back the control plug. In master ring, both of those shear lines can operate the lock, but there's no interchangeable core in master ring. So the 2 shear line idea exists in very different purposes, and we'll reveal later on in the video.
Just a moment. Sorry, I missed that. Could you say it again, please?
I don't believe I said the go word for that telephone. They're listening. And we'll discover maybe a link between interchangeable core and master ring in a bit. Master ring cylinders are indeed fully field serviceable, especially with our PK1070 Deluxe pin kit. Master ring can be done in 5, 6, or 7 pin with limitations, as I said earlier. You're going to need to top load it unless you were to use a tool like the Keydex Easy Loader Bible plug following tool. The problem with that is it's not available for a 552 plug. So you're going to be top loading. So if you're going to do mastering, definitely make sure that you have spring covers. Okay, there are some in that kit naturally. Now here is talking about some of the muscle flexing of the technology of the master ring cylinder. In a 7-pin system, I'm just going to throw it out there at you. In a 7-pin system, System 70, in a total position progression environment, the master ring cylinder, speaking only in regards to the ring shear line, just the ring shear line, that's going to give you 15,625 theoretical master keys under a TMK. Okay? That's only at the ring shear line. We've not even pinned the plug shear line yet. Saying 15,625 a different way, you could have under your great grandmaster key. Let's say it a different way. You could have 625 masters under each of 25 grandmasters under that great grandmaster key. So 625 masters under each Grandmaster under the Great Grandmaster. So that's a lot. That's a level 4 system. All of those masters are independent of the change keys. The preceding is only in reference to the Master Ring key bitting array. Because there are 2 shear lines, there are 2 key bitting arrays in Master Ring. Okay, there will always be at least 2 KBAs when you're using TPP. There can possibly be more. If you're using rotating constant, there very likely will be more than 2 key bitting arrays. The second key bitting array, our change key bitting array, in the same 7-pin System 70 environment, you could have 233,280 theoretical change keys using TPP. Under each master, and no chance for incidental keys, and no chance of a master or a change key ever duplicating the Great Grandmaster. So what we're saying is 7-pin environment, System 70. In the change key, you can have 233,280 theoretical change keys if you're using total position progression under each of those 625 master keys. Okay. There are no chances for incidental keys. There are no chances to have a change key unintentionally acting as a master or a top as a master, a grandmaster, or the TMK. There's no chance of the Dayton method. The only downside, according to GL Jerry Finch in Book 3 of Servicing Interchangeable Cores and Master Ring Cylinders, the one downside to all of that is the change keys under a master key on a single keyway will operate their counterparts under each master key. So as you are running through your key bitting array, you're going to generate changes under those different masters. Those change keys will operate other cylinders, so you need to put some thought into that. With 233,000 theoretical change keys, you may not bump into that problem, but if you did, and he says, Mr. Finch said it's not much of a problem, in not being a serious problem, is if the biddings under each master are utilized in a sectional keyway environment, or just being aware of the possibility where those keys could work each other and where they're placed. You might have a campus where you've got, a dozen, dorm buildings. Okay, well, it's a Big Ten university. That campus is 3 miles. That dorm building is 3 miles that way. So you may not have a problem. If you think there is, set up a system in a multiplex environment. You could do this H class. The H keyways are H1 through H8, 233,000 theoreticals under each of those sections, times 8. Okay, lots of keys. That's where your muscle flexing comes in. So those above theoreticals are all possible if we make one chamber of the TMK KBA constant by using that chamber in the TMK KBA. So how we achieve those change keys is as follows. We're going to go over it, then we're going to look at some stuff on the screen. The above theoreticals, the quantity of 233,000 theoreticals, are all possible if we make one chamber of the TMK KBA constant by using the bitting of the TMK in that chamber of the TMK KBA. So what that means is, in our TMK KBA, there will be a chamber that's constant in all of those. Use a number 1 in that entire chamber, let's say. So we then hold out the remainder of the bitting of the TMK from the balance of the chambers in the TMK. In the change key KBA, we hold out that one TMK that was held constant. So in that chamber where it's a constant 1, in the TMK KBA, don't use that as in that chamber in the change key KBA. That means that your changes will never have that 1 cut in it, and they can never operate at the ring shear line. That's how that's accomplished. And of course, vice versa, you won't be able to have a master duplicating a change key. So if we included the TMK bitting in the change key KBA in 6 of the 7 chambers, and in that one chamber, again, we held out the TMK bitting, we do yield the 233,000 changes. So what we're saying is, if we took the TMK and we included its cuts in the KBA for all of but the one chamber, which is the absolute first substantial, that is the departure from traditional master keying in single shear line environments. You should be saying in your head, that does not make sense. Well, in Master Ring, it's the way to do it. You can then progress those numbers safely to yield the amount of theoreticals. Traditional master keying logic tells us to absolutely not include the TMK bittings in the change key KBA, but in Master Ring this is permissible and endorsed by the manufacturer. I do believe it's beneficial to progress the TMK KBA, the TMK bitting in the change key KBA, as to help disguise the TMK bitting in the change key bitting array, except in that one chamber where it's held constant in the TMK KBA above. If we exclude the TMK bittings from the KBA and we had a large enough sample of cut change keys, one would have less educated guesswork involved in determining the TMK KBA, but only because those precise values are excluded from the change key KBA. What I'm saying there is, if you had your standard single shear line logic and not progressed the cuts of the TMK in the change key KBA, if you had a large enough collection of keys, you could say, okay, well, what numbers am I missing? That's a tip-off. But when you progress them, which is completely mechanically safe, you don't have any tip-off. Like, well, okay, I have no idea what that master key could be. Okay. We better switch to the screen view and take a look at this. Now, if we switch over to our view of the screen, the above theoreticals are all possible if we make one chamber of the TMK KBA constant. Let's take a look at see what I mean by that. That is your TMK KBA. This is your one constant chamber. Okay. 7-pin chamber. Here's your TMK. You're going to progress this, whatever your sequence of progression is going to be. You're going to be able to achieve 15,625 masters under this TMK. We then hold out the remainder of the bittings of the TMK in the rest of our TMK. In the rest of our KBA. There's a 2 in the TMK, don't use a 2 down here. 3 here, don't use a 3 here. Okay? Chamber 1 is missing the 2, so on and so forth. Chamber 5 is constant. In the change key KBA, added with our TMK KBA, you can see what we're doing. Now I'm progressing every possible number down here. I'm progressing every possible number, except that I'm not progressing the 1 that was constant up here. This is going to give you 15,625. This will give you the 233,280 possible keys. Okay, that's your TMK, and that's your change key KBA. The Corbin Russwin cylinder manual does indeed use the TMK KBA in the change key KBA, except in one chamber. Now this is an excerpt out of the cylinder manual. They're doing a, the book says, they're using the 7 here and they're holding it out here where all other numbers are used. Okay, it's the same principle. You are preventing any of the change keys from operating up here, and you are preventing any of the master keys from operating at the plug shear line. So none of the change keys can make the master ring shear line operate because they don't have the 7. And because they all have the 7, none of the masters will turn the plug shear line. That's the important part. Let's switch back to the camera view. So talking about our theoretical keys, our theoretical change keys is what we're talking about. Now, 15,625, 233,280, those are theoretical keys. That means keys that, prior to you excluding out those keys that are poor etiquette. First of all, poor etiquette would be like a key cut to 22222, or any chambers that have the same bitting in more than 2 chambers successively. You would exclude all of those. Also, your maximum adjacent cut specification. What is the max? In our System 70, the max may be 4. I think I had said earlier it was 5. I'm going to look in my manual, and I'm going to show you where you will find this as well. Our System 70 DH class has a max of 4, a maximum adjacent cut specification. I earlier said it was 5, it's 4. What that means is if you have a cut in one chamber, the cut next to it can be up to and including 4 different in depth. So if you've got a 1 here, you can have a 5 in the next chamber, but you can't have a 6 in that chamber. You can have up to and including 4 greater than that first cut, or less. So in your theoreticals, you're going to exclude all of the keys that are violating your maximum adjacent cut specification. Any key that has a 0 and a 5 or a 6 next to it, those are all gone. Any key with a 1 and a 6 next to it, those are all gone. Any key with a 6 and then a 1 next to it or a 0 next to it, those are all gone. So those are that's how you'll get rid of get rid of the actual keys that will chip away from your theoreticals. There's another example that I'll give in a little bit of another key that you should exclude from your calculation. So theoretical keys means before losses for max, before poor etiquette. If you need more change keys, if you need more than theoretically 233,000 change keys, again, set it up in a multiplex environment. You would be able to have like an H series standard keyway, and I believe there are 8. In the 93 restricted keyway, there may also be 8. So you would be able to take your bitting and photocopy it from H1 to H2. Now you've got double the amount, different key section. The keys won't pass each other. But then on top of there will sit the multi-section blank, the blank only, that will enter both of those cylinders. So now you can really increase how many theoretical keys are possible, well over 1 million keys, to handle whatever your requirements are. According to Corbin Russwin, they have never seen any type of restriction placed on Master Ring given any Corbin or Emhart or Russwin keyways. You can't do high security in Master Ring. There's no possibility of high security. Modern Access 3, Pyramid, the interlocking pins for high security, none of that's available in Master Ring. But you can do restricted blanks. So doing a Master Ring system on restricted blanks would be awfully nice because you're just not going to pick up some of these key blanks. And while it's theoretically possible to order them, you're going to have to do a lot of forgery to get that to happen. And that's just not realistically going to happen. The factory maintains records of restricted blanks. So I would expect that the ability to get your hands on restricted blanks for someone to get restricted blanks in your system to be almost non-existent. What 3D printing does is a different conversation, but that affects any key blank. any key blank in the world. Pin tumbler cylinder design, moving forward, is premised on the single shear line concept, where all pin combinations allow change keys, masters, grandmasters, etc. to operate a cylinder. And those pins for those different keys vie for operating space with each other. Depending on the number of key levels, the number of changes required at each level, known as the expansion specification, number of available keyways, whether or not your prime keyway belongs to a multiplex family, the master keying methodology used, TPP or RCM, tens of thousands of key changes can certainly be accommodated. Modern single shear line cylinders are an extremely capable format onto which to build a keying environment. There are, however, a number of downsides to single shear line cylinders versus our two shear line cylinder master ring. Incidental keys, first and foremost. You are always going to have incidental keys, okay? That will succumb to the Dayton method super quick. Especially in any keying methodology. You could certainly accomplish that with rotating constant, where you have less masters per cylinder, but in total position progression, where you have masters in all the chambers, yeah, that's a problem. And that's a problem because you're creating additional shear lines that can be exploited by picking, impressioning, shimming, Dayton method, okay? The advantage of mastering is that it eliminates the key interchange in your system 2 levels. So to say that again, in system 2, in level 2 systems, it eliminates key interchange. It doesn't exist. In level 3 and above, it substantially reduces it. Okay, if you were going to Dayton method attack a master ring cylinder, you would already have to have a master key. Okay, so if you've already got the master key, and you want to, you're going to go from the master key to the TMK. Well, you've already got a master, so there's probably certain rights and privileges that go along with that. I don't know how much of a problem that really exists, because someone with that power is already going places within the physical structure of the building. Let's take a closer look here. Now, proper key bitting array generation is discussed thoroughly in the Corbin cylinder and keying manual, which I state is easily the most valuable document as it pertains to a single manufacturer's attempt to state plainly every facet of their keying systems, rules, features, and guidelines of a specific keying system that is freely available to all. I have a printed copy of it. That's great. I don't use that. I use the PDF. Anyone can get that PDF. It's on their website. And it's just glorious that the document exists. It's dated because it doesn't have some of the new stuff in it. But for conventional, for mastering, teaching you how to master pin their interchangeable core and their mastering via the build-up pins, that's all freely published and available for you, ready to go. Okay. We'll finish this paragraph, then we'll hop to the manual. In the manual, they talk about 2 methods of key bitting array progression. Both of them are pre-System 70 examples, so they're 2-step. I don't know that this document, this document certainly doesn't predate 1970, but I think because of Master Ring and it being predominantly pre-System 70, before 1970, that's probably why they're using that example. There's 2 methods, the standard method and then method 2. Method 1, method 2 is where they show a systematic shifting of parity. Now that's really super breaking the rules. You are, in a 2-step system, you're going from, you're using single-step parity, where you have to have, where you're excluding parity. You're going, from a 2 to a 1 kind of scenario, but they're doing it methodically, so that they're doing it intelligently. Now, when I study that method 2, I don't see their advantage from a perspective of increasing the possible changes available to you, but it has been suggested to me that shifting parity will yield you more potential changes. In their example, they don't yield more changes. Now, the advantage of shifting parity could simply be to randomize numbers. You know, if you're trying to Dayton method attack this and you know that it's pre-system 70, but in one key you've got a 2 cut in the 6th chamber, but in another key you've got a 1 cut in the 6th chamber, that should say to you, how can that be? That's clearly a mistake. You know, this is 2-step system. That's not the case with Master Ring, because of how we're isolating the two share lines from each other. Corbin Russwin recommends the rotating constant method of approach in the TMK KBA to reduce the number of incidentals. So, in total position progression, probably the system that we're all most familiar with, you have a master pin in every chamber. In rotating constant method, you don't. Depending on how many positions, how many chambers that you progress and how many you hold, you will certainly use far less master pins, because in your RCM TMK KBA, you're going to have some of the master key biddings run right down. Okay? But where you are progressing that chamber, you'll have a master pin. Now they're saying use RCM because while you'll still have incidentals, you'll have far less incidentals. And what you'll have to decide, which is outside of this conversation altogether, researching rotating constant method, how many positions would it be best for you to progress and hold to yield the number of change keys? That is a subject well outside of this discussion. But this would be the document for you to look at. It's just, it is utterly full of RCM approaching it from every method. So you'll want to study that. Absolutely. Rotating constant, having factory generated bidding lists for projects, they're using rotating constant. Just in a level 2 system. Why? Well, because the number of changes will be accomplished. You're using a lot less master pins, physically not wasting pins, and it's a more secure cylinder. It is, in lots of instances, especially level 2, it is certainly, in my opinion, the preferred method to go. Corbin Russwin says so as well. Now, okay, when the change key is being used, the ring shear line remains locked. Okay. When the master key or the TMK is used, the plug shear line remains locked. As a result, it's structurally impossible to attempt to partially derive an MK or a TMK bidding, because the plug shear line and the ring shear line cannot rotate at the same time. Even though, as I said very early on, you could cut keys that would allow that to happen, you would exclude those. You would never use those. Which means you are cutting a change key and then a master key that is the same cuts across the board, which would yield 0 buildup pins in all of those chambers. Okay. Master Ring reduces the negative side effects of cross-keying, either controlled cross-keying defined by the list council as a condition in which 2 or more different keys of the same higher level, two or more different keys of the same higher level keys operate one cylinder by design. Or uncontrolled cross-keying, a condition in which 2 or more different keys under different higher level keys operate the cylinder by design. Okay? Either condition severely limits the security of the cylinder, the maximum expansion of the cylinder, and often leads to key interchange. Moral of the story, don't cross-key. When you cross-key, you create incidentals. When you theoretically, when you extract all of the possible keys, like we did with the incidental exercise I showed, 2 to the 6th power, and then you'll have all the keys that can theoretically work. You then need to go to your KBA and pull all those change key possibilities out of the pool of possible keys that you will use. So, you know, it's handy to Maison key that front cylinder of the building. There's no doubt. And If it's a vestibule and it's rarely locked anyway, it's probably not a bad idea to do it. It's awfully convenient if it is locked. The downside of that, though, is you create a ton of incidental keys. With someone with some knowledge could derive some incidental keys, and maybe they'll work in the other system. The other problem with Mason keying is, you've got a cylinder on the front of the building. You've got 3 floors in this. You've got 3 stories in this building. The master and each of the 3 keys, each of the masters for the 3 tenants, let's say, their keys, will operate that cylinder. Well, what happens when tenant 2 moves out? You've got to go rekey the Mason keyed cylinder to pull that bitting out and put a new one in. So it is awfully convenient, but long term, you need to be prepared. Short term, you need to be prepared to pull those incidentals out of your key bitting array. Long term, you have to be very willing to engage in maintenance. Anytime someone moves out, or anytime someone rekeys their building, their unit, they're going to have to rekey that Mason cross-keyed cylinder. Now, availability. Moving on to another topic here, the availability of the cylinder. You can get Master Ring in rim and mortise cylinders. I've showed you both. You can get it on, you can order that on unit locks, mortise locks. You know what, before we get to availability, let's get to the screen view and look at our Corbin Russwin cylinder manual. Now, in our article, Freely, the Corbin Russwin Cylinder and Keying Manual, easily the most valuable document as it pertains to a single manufacturer's attempt to state plainly every facet of their systems, rules, features, and guidelines of a specific keying system that is freely available to all. And here it is. Okay, now 108-page document. If you deal with Corbin Russwin, even on an occasional basis, I do not see it being possible for you to successfully execute work without this manual because of this reason alone. This has nothing to do with you or your skill. It's like being able to open a padlock without the combination. Sure, you can get it open, etc., etc. But if you don't know the rules by which the combination needs to be turned, it's going to be awfully difficult to get it open. If you don't realize it's so many rotations to the right, so many to the left, so many to the right, or so many to the left, it's tough. Corbin Russwin says, okay, here's the playbook. Here are the definitions. And that's what this document does. So having the rule book is good, but the reason there's a rule book is because at this moment, Corbin Russwin, P.F. Corbin, Russell and Irwin, Russwin, they have been in business for basically 170 years. Imagine a company making keys for 170 years. Things have changed in 170 years. Evolved, I should say. And they immediately get into talking about what are the depth systems. Okay? You could look at this stuff and say, I never knew it worked that way. If you try to generate X class like a, if you try to generate 59 series keys, but you're using X class information, it will be maddening if you try to do that. So be mindful that this document will allow you to navigate the unknown regions. So when we get to mastering, we're going to go right to about page 37 or so. Mastering, page 33. This begins the definition of talking about mastering and how it works. Okay, the Exploded View does a really great job showing everything. The mastering cylinder was patented by Edward O'Keefe. We're going to get into that in a little bit. And this will talk about and sing all the praises and hallmarks of the system. This teaches you how to combinate it. It's really easy. And we're going to go over that as well. But this is just a topical familiarity with the entire manual. They go on to allowing you to not only combinate it for a simple level 1 system, Well, no, pardon me, a level 2 system. But then adding master pins for a level 3 and beyond system. More examples. Then, method 1 and method 2. This is the shifting of parity, as you can see. So the KBA gets stacked because you're shifting parity in here. Reading all of that, if you're going to do mastering, you're not going to learn how to pin mastering from this video necessarily. But having this manual is where you can confidently be able to do that. I mean, the goal is that you leave this video knowing how to pin mastering. But this is the original document on how this is all done. This manual talks again about the history of all the keying classes. That's in the beginning portion. They get into defining terms, talking about plug diameters, key blanks themselves, the history of the bows of the Corbin and Russwin key blanks. They get into keys and the key ways, the key sections. Okay, so Corbin 59, 57, those are different classes. One is Z and one is X. Z class, X class. More keyways. Here is the system that we're working on in this article. H series. It's a DH class bitting, which is discussed on 62, 63, and 65 for depth and spacing charts. Available 5, 6, or 7 pin. So what I like about this DH class is that it is part of a multiplex environment, as we talked about earlier. There are 8 keyways. What I also like about it is that the plug is highly paracentric. Okay, you've got a lot of cutbacks. Paracentric means that the vertical axis center line is basically crossed multiple times with the key. Okay, so you really cut across. Alternate H, which everything is reversed. Well, actually, structural is useful when keying goes in a different direction than originally anticipated. Russwin 981, that's very common. 981 class, those 3 keyways, you can buy Kaba Ilko cylinders that are 981, which is Russwin, by the way. Continuing to scroll through, then you're going to get to conventional cylinders. They're going to teach you how to pin conventional cylinders, except you do need to have an understanding of how it's done. But this is combinating conventional cylinders here. Well, in this section, this is an intro section. This will teach you how to combinate a cylinder. When you get to mastering, you will have needed to have familiarized yourself with combinating. Interchangeable core. This is where the build-up pins. If you do any IC core work, IC work. Corbin Russwin, here it is. They'll go to the old style as well, which I've never done. I've never even seen the old style. From what I understood, it was just a bit of a hassle to pin those with the moving control lug and whatnot. Master Ring, which we've done. High security, the interlocking pins. Then we're going to get into ultimately some special functions of cylinders, like a Brinks function. That's a really neat cylinder function. You can turn the key one way, but you can't the other. Hotel function is really cool. In the current way that they do it, you can see why Master Ring is not going to work with hotel function. This is their conventional cylinder hotel style. And was inherently different compared to the Master Ring hotel style in Robert Sivking's book. Interchangeable core, padlocks, how to construction master key is listed. Okay, how to generate biddings. Pins, now we're going to talk about the actual pieces that are used to combinate. Then we're going to get into the depth and spacing charts. This is the one that we're working on. Corbin Z and DH class, System 70. Applies to these keyways. Max of 4, increment 028. It's a single-step system. Cuts 1 through 6. I said earlier 0 through 6. I was obviously wrong there. 1 through 6. There is no 0 in this. Pin lengths, if you measured them with your caliper for 509 and 552. Your bottom pins and your build-up pins will be specific to each. Your master pins come into play. You continue to scroll through the document, you're going to get more depth and spacing charts. And that's really the crucial information, being able to know what is, so to speak. Cross-references between old numbers and new numbers are back here as well. And then a glossary to finish it off. Anyway, so this document is hugely required reading when you deal with Corbin Russwin. Now, the availability, you're going to be able to do rim cylinders, mortise cylinders, in unit locks, mortise locks, windstorm rated material, and exit device trims. You can read this section to see everything that's available. If you're going to be specifying a project, the obvious thing to state, there is no grade 1 lever that is cylindrical in design that's mastering. You can do the unit lock, and the unit lock is not cylindrical, but it will give you the one lever they make, the Essex. And unit locks are outrageously durable. They're also incredibly expensive. They do have a grade 1, they discontinued their grade 1 knob lock. But the cylinders can be purchased. Okay. Now, flexible head. Let's talk about the flexible head cylinder. Let's switch to the camera view for that. Now, the flexible head cylinder. When you're doing mortise locks, you're going to get flexible head exclusively. The head on this actually is attached to a spring, as you can see right there. So, not having actual experience with where you would use a flexible head, I contacted the factory. And it's all detailed in the article, but the bottom line is this. They had initially said, in one conversation, they said it's to account for irregular door surfaces. I thought, well, that's odd. I don't encounter irregular door surfaces. I mean, you're talking about the grain of a wood door or an FRP door? I don't encounter that very much at all. But then they also said minor variations in door thickness. And as I pondered that, I began to realize why that was important. Minor variations in door thickness. Well, I thought, a door doesn't vary in its thickness. It is 1 3/4. Well, when I pondered it, I realized, okay, they're not talking about a door, they're talking about doors. I can tell you, and then it dawned on me, my actual experience occurred to me. I've manufactured wood doors in the past. So I can tell you that wood doors will vary in actual thickness. 1.71. An inch and 3/4 door is never 1.75. Okay, it's sub 1.75. I've even measured them, especially fire doors, below 1.7, 1.69, 1.72, 1.71. They fluctuate. Let's talk about plastic laminate doors. Okay, what grade of PLAM will be used? Standard, post-form, or vertical grade? They're all different in thicknesses. How is it constructed? Did someone take a pre-manufactured door and then put vertical grade, which I believe is the thinnest grade? Vertical grade, yeah, vertical grade is 029. So if you had 2 layers of 029 on an 1 3/4 thick door, let's say your door is 1.71 and you added 60 thousandths. Yeah, you're at 1.77 basically. Let's talk about a school project. You could certainly have some PLAM doors in a school or a hospital. A hospital would be a great example. Sorry. A hospital would be great. You'll have PLAM doors everywhere. You're also going to have some heavy-duty steel doors somewhere. Now, have you ever measured a 16-gauge steel stiffened, or even a 14, or certainly a 14-gauge steel stiffened hollow metal door? That's 1 3/4. I assure you, it's not 1.75. It's 1.875. So the variety, the variations in door thickness means, think about all the different doors that exist in the world, and when you put a caliper on all those different doors, aluminum, FRP, wood, steel, bronze, brass, they're going to measure different. Enter the flexible ring. Basically, as I rotate this, what do we need to do? Lots of surface area now. This is a bigger cylinder. I need to get that key pointed up. The fact that that ring, that head, will flex with me, will give me another 2 revolutions, basically, is going to permit me to get this installed in the environment where I've got some 1.72, I've got some 1.73, I've got some 1.875, will permit me to get the lock installed. I also thought, when they said, it also did occur to me that you might be compensating for maybe a lock pocket that's not exactly correct. If that mortise cassette is not utterly parallel with the face of the door, that cylinder's going in crooked. So the ability of this thing to kind of just give you that small amount of flex on the head of the cylinder, that's crucial. This is 611, by the way. 611. When's the last time you saw a 611? 611 is polished bronze. Not easy to see on the camera. Polished bronze. I do regret the fact that when they packaged this, they put the keys in with the cylinder, and it damaged, it dented, it scratched the lacquer. Because this is for sample review, wasn't an issue, but they need to isolate the metal parts from each other. Moving on down into the, so we talked about flexible head. That's what that's for. Okay. You can get these in dummy cylinders. You can get them in rim cylinders. Rim cylinders can come with the tailpiece oriented however you need. What's really great about Corbin Russwin in terms of availability? Lots of finishes. 611. Who would have thought? Polished bronze. Powder coated. Asa Abloy and their companies underneath, your Corbins, your McKinneys, your Rockwoods, your Sargents, your Yales, Pemco, Adams Wright. Black powder coat. It's the new fancy popular finish, and has been for a while. But they're accommodating those requests from the marketplace, and that's really great. That you get choice when it comes to finishes. Okay. You're going to be completely capable of specifying a keyway. Like I said earlier, they'll probably be able to accommodate that. You can do restricted keyways. Patented keyways are available, not high security, like I said. You'll be able to do a full deployment of hardware, obviously compliant with A117, the accessibility code. Now the history, let's move to the history, and I'm not going to spend a ton of time here because that's a large section of the article, because I did some deep dives into some very old catalogs, and I want to show you some of those old catalogs. There is, the Master Ring was patented by Edward O'Keefe. I can't find anything on Mr. O'Keefe. New York City locksmith in about 1889, I think. You can click on the patent and look at it there. I forget the date, the year. 1889. And that cylinder is there. The dual shear line cylinder is there. He then assigned it to the P.F. Corbin Company. So I imagine he sold it to them. Hey, I got this great invention. You interested? Yeah. How much? Write me a check. Okay. Um, in the history section, which I'm not going to dive into, but you may enjoy reading it, I'm going to switch to the camera view because I'd like to show you the source material for that section of this article. Now, in our history section of the article, we talk about the patent that you can link to here. And I say I have several late 19th century and early 20th century P.F. Corbin catalogs. Not the original catalogs, but the scans. So click Scans, and you're going to be able to get to the Corbin Russwin page in my site. And sure enough, over here are some really old catalogs. 1895, 1905. Those are 2 years that you're going to look at. What's really neat in one of the older catalogs, I forget the year, could be 1876 or 1885. They had bit and barrel type bit key construction. They had pin tumbler construction and flat steel key construction all in the same catalog. So if you really wanted to see what Corbin Russwin had in 1905, you let that really huge file load and you're going to be able to see what they offered. So that's really, it's for fun, really is what it is. Talks about the ball bearing, the evolution of it. Okay, different trade magazines that the factory had advertised in over the years, touting the hallmark, the benefits of their product line. Okay. Now, in the history section, what I did want to focus on was Mr. Sivking states that Master Ring is the underpinning for all interchangeable core service. So it makes me think that the Master Ring is responsible for interchangeable core cylinders, you know, ultimately being concocted, thought up, devised, brought into the world. And if we look at the O'Keefe patent, when we study this, we sure see our two shear line principle. Okay? We've got our key over here. It's obviously driving something on the inside. I admittedly don't know what sort of lock mechanism this is. Okay, but then you've got the other shear line, which is not satisfied because the plug shear line key is installed. Two shear lines is the bottom line. Now, when we look at the patent, switching gears, Frank E. Best, the gentleman who invented the small format cylinder, patented in 1919, 30 years after the Master Ring was patented. Here's his patent. Before we open that up, the ball bearing concept, Corbin states that is a Corbin invention, giving you very smooth operation. We look at the Frank Best patent for the small format. If we look up over here, we definitely get the idea. If you're familiar with small format, you get the control lug concept here, right? That's your control lug. That's pretty cool. Multiple shear lines. That's what we're driving at here. Multiple shear lines. But what's also neat is the tip of the hat to the ball bearing concept that Frank Best did. A Corbin invention. And what's interesting is we study this key enter and it will satisfy the plug shear line. When you pull that key out one position, you satisfy the plug shear line. Pardon me, the control shear line, allowing that to work. That's obviously not how these work today, but that's how it was patented. But the ball bearings, I thought, was interesting and served, in my mind, to bolster the statement by Mr. Sivking that Master Ring serves as the underpinning of all interchangeable core work. Okay. Now, keying theory and KBA creation. Most of this is all encyclopedic that's here. And this is a sample key bitting array that I arranged. Okay. Z-Class System 70. Our TMK KBA here, and our change key KBA, following the rules previously outlined, gives us these theoretical changes, the mathematics showing it. 5 to the 6th power, because this 5th chamber is constant. 6 to the 6th power, we've got 6 chambers that have 6 possibilities in each chamber, but then we've got a single chamber with 5. That's why I've written it this way. We have our sequence of progression. I made it this very odd SOP, as it is up here as well. Different only to serve as complete randomization of the keys. Okay, you don't have to do it that way. It's just a, if we're muscle flexing 7-pin master ring, let's muscle flex. That's all that is. Now, what this is going to get to is understanding how the structure is put together. And reading the preceding is the welcome mat, so to speak, of approaching the creation of that TMK, of these KBAs. Okay. Notes on the KBA you can read, and it's all based on TPP, total position progression. I go on to state that you could implement RCM and what you would get if you were progressing X chambers out of all of them. So if we were going to progress 4 chambers of the 7 and hold 3, what your payoff would be. You take the payoff of each of these sections and determine if that's going to meet your requirements in your key expansion specification. Will you be able to give your customer the number of keys necessary? And will you be able to allow for future expansion if you're using 50% as your marker for that? Okay. I go on to talk more about the methods in the cylinder and keying manual. Talk about a method 3 where we use every possible cut. In their pre-System 70 example, you have to think about, not being more than 1 increment away in all of your chambers. As long as 1 chamber is more than 1 increment away, you shouldn't have any trouble. But in my conversation with the factory regarding a, not observing parity in a 2-step system, if you were to stay a full step away above and below, you wouldn't have any trouble. Now, combinating. And that's kind of, I hope, what you're here to see. Let's combinate a cylinder. This is all derived from the cylinder manual and from other sources, which would be Jerry Finch's book, which would be Mark Tobias's book, which would be Mr. Sivking's book on how to cut this material. So to do a level 2 system, you're going to pin the plug shear line. And what I've attempted to do is to just distill into its essence what needs to be done. Level 2 system, change key and master key. Pin the plug shear line to the change key. Now, the new information If your TMK is cut deeper than your change key, you'll use a plus build-up pin. The example is if you have a 2 change key and your TMK is a 5, use a 3 build-up pin. If it's shallower, you'll use a negative build-up pin. If your TMK is the same cut, use a 0. If your TMK and your change key are the same cut, use a 0 build-up pin. Add your top pins and your springs, secure your slide cover, and you're done. Okay? A level 3 system is the same concept, except that you're going to bring into the mix your master pins. But let's take a closer look at that level 2. Now what I'm going to do is generate a change key, I'm going to generate a TMK, and I'm going to generate a master key. And then we're going to show on our screen what this is going to look like. Pardon me, we're going to show on the camera how we're going to pin this material. So let's do that now. I'm going to cut the keys and I'll have them cut and we'll be right back. Now what we have here is our Corbin Russwin M-Hart System 70. DH series. We need cutter 90 CW90MC, which I've installed. I'm going to slide that card in. Okay. Now these are the numbers that we're going to cut. I'm just going to cut the first chamber only because we just really need to illustrate this in one chamber at a time. Okay. It's not a good sign. Okay, let's see if she works now. What did we forget? Oh, okay. So that's a mistake on my part. Rookie mistake. There's a micro switch installed. We're going to cut a 2 in the first chamber. Okay, now what we're going to do is we're going to get our depth and spacing chart and see if that 2 was cut correctly. We're doing a 2 should have a root depth of 311 thousandths. Okay, so let's see if we've got 311 thousandths of a root depth. Yeah, the cutter is, we're got about 312 thousandths. That would be considered within tolerance. Okay, so let's go over this book a little bit here. What we've got here is DH class, which we're doing, System 70. A 2 cut is 311 thousandths. That's what that is. So we verified that we're cutting the right stuff at least. You know, before you go through starting to cut a whole bunch of keys, certainly be a great idea to make sure you're cutting the right material. So let's cut a 1 and then a 5. And that H is such a thick key blank, you want to be sure you're cutting the right end. So we're also going to now cut a 1 in our first chamber, which won't be much of a cut at all. Its root depth is 339 thousandths. And the last time I cut it, it didn't even scratch the surface. It's not even cutting. So the question is, what is the height, the blade height? 339 on a 1 cut. Okay, so so a 1 cut is basically no cut. Is basically what it is. Let's change that to a 4. So at least we'll get a cut out of it. I'm just going to assume it's cutting accurately. I'm going to turn the machine off because we're going to switch the key. And I don't want that micro switch to trip it when it comes back up. Now our change key is going to be a 5 cut. Okay. So a 4 has a 255 thousandths and a 5 has a 227 thousandths. So this should be 227 thousandths. It is. I mean, it's 10 thousandths off. So the 4 cut is 255 thousandths. And again, it's 100 thousandths off, or 10 thousandths off. A thousandths, forgive me. Now, let's take a look at combinating. So we're going to cut a 2 in one chamber, a 1, and a 5 in this chamber. Let's get this video started. Now what we have here is our Corbin Russwin M-Hart System 70. DH series. We need cutter 90 CW90MC, which I've installed. I'm going to slide that card in. Okay. Now these are the numbers that we're going to cut. I'm just going to cut the first chamber only because we just really need to illustrate this in one chamber at a time. Okay. It's not a good sign. Okay, let's see if she works now. What did we forget? Oh, okay. So that's a mistake on my part. Rookie mistake. There's a micro switch installed. We're going to cut a 2 in the first chamber. Okay, now what we're going to do is we're going to get our depth and spacing chart and see if that 2 was cut correctly. We're doing a 2 should have a root depth of 311 thousandths. Okay, so let's see if we've got 311 thousandths of a root depth. Yeah, the cutter is, we've got about 312 thousandths. That would be considered within tolerance. Okay, so let's go over this book a little bit here. What we've got here is DH class, which we're doing, system 70. A 2 cut is 311 thousandths. That's what that is. So we verified that we're cutting the right stuff at least. You know, before you go through starting to cut a whole bunch of keys, certainly be a great idea to make sure you're cutting the right material. So let's cut a 1 and then a 5. And that H is such a thick key blank, you want to be sure you're cutting the right end. So we're also going to now cut a 1 in our first chamber, which won't be much of a cut at all. Its root depth is 339 thousandths. And the last time I cut it, it didn't even scratch the surface. It's not even cutting. So the question is, what is the height, the blade height? 339 on a 1 cut. Okay, so so a 1 cut is basically no cut. Is basically what it is. Let's change that to a 4. So at least we'll get a cut out of it. I'm just going to assume it's cutting accurately. I'm going to turn the machine off because we're going to switch the key. And I don't want that micro switch to trip it when it comes back up. Now our change key is going to be a 5 cut. Okay, so a 4 has a 255 thousandths and a 5 has a 227 thousandths. So this should be 227 thousandths. It is. I mean, it's 10 thousandths off. So the 4 cut is 255 thousandths. And again, it's 100 thousandths off, or 10 thousandths off. Oh, thousands, forgive me. Now, let's take a look at combinating. Okay, now, here's where the combinating part of the video comes into play. So, we've got our cuts, 2, 4, and 5, and we're just going to do the first chamber. And we're only going to do it with the AA and the 1AA, right? Or the AA1. Imagine if this was just your AA key and your 1AA in a level 2 system. This represents a level 3 system, so we write it this way. The bottom line is we're going to take our plug here, our rim cylinder, And I'm going to simply, I'm going to drop a spring inside of there, and I've got all of the original parts pulled out, as we did earlier. So I'm going to put my spring inside of there. Now, they have these really huge spool pins. They're just epic. I'm not sure what size it is, but let's take a look. I think it's the 420 thousandths length spool pin. 0.416. Yeah, 0.415 is the size of that spool pin. They're all spool pins that were in there, which is actually absolutely the opposite of what Corbin Russwin says. You should never use spool pins in all positions because of the possibility for it to not be, unless they put them in upside down, but the possibility of them not to work correctly because of the movement. I'm going to drop the plug down in there, the master ring, the master ring. Be easier to do it from the front. This is why top loading is the way to go with this. It's not realistic to pin this otherwise, or to load it otherwise. Doing it with a plug follower is not. It's just not realistic. You know, it's hard enough to just put the one driver pin in. So we have our plug. This is the original plug. Okay. These are O-bitted, so I'm expecting these to be one cuts, which according again to our book should be 339 right there, 0.339. So what I want to do is I like to put them into the kit. But I'm not going to because I want to reuse these to put them back when I put this back together. Okay. So now our first cut, if you recall, is a 2. So I'm going to get a number 2 bottom pin, which is 231 thousandths according to our manual. So 231 is right here. I'm not a tweezers guy. Okay. We're going to get our number 2 cut on our key. Make sure that that looks nice and pretty. Indeed it does. Okay. Got number 2. Now, we've got only one pin, one chamber pinned. I'm going to put that in there, and I'm just going to make sure it works. Indeed it does. It works just fine. Now, obviously when I put my 5 cut in there, it's not going to work. Whoop. And when I put my 4 cut in there, it's obviously not going to work. Okay. My 2 cut works just fine. Now, here's how we combinate this. We need to, and we would be top loading in this instance, but we're not top loading. We're going to make it so that that 4 works. So in this instance, because the master key is deeper than our change key, we would be using a plus build-up pin. Let's take a look. Thought I heard something click. Oh, it's still in there. Oh, now it's out. You know the routine. I'll put that back in real quick. This is where you definitely need tweezers. I'm I'm going to put it with the spool end down because it is the only pin in there. Okay. Now, what it says here, according to the manual, according to the book, bottom pin, that's your change key cut. Change key cut. Your build-up pin is your shallowest master cut minus the change key. That's a bit difficult to understand, but you would start at the shallowest master cut. The issue is here they're doing a level 3 system, and we're just doing a level 2 system. And that's why when I broke it out in my article, I've done it as level 2 and level 3. The bottom line is this. You have a cut on your change key. It happens to be a 2. You have a cut on your master key. It happens to be a 5. We're just using 2 and 5. The 5 is bigger than the 2. You have to use a positive BUP, a build-up pin. Now the BUP, a number 3, if you've not deduced that already, is in 552, a 3 build-up pin, positive 3, is 0.226. Okay, so I've got to find a 0.226 build-up pin, and then I've got to get that into the cylinder. And it's a hassle because we're not top loading. It's a hassle when you top load. So we said a 3 build-up pin is a 226. So I'm looking for a 226, happens to be right here. This is certainly where you would use a tweezer. Move that back a little bit. Okay, let's try that again. Oh. It's like watching paint dry. This is why they're top loaded. As Mr. Sivkeen says in his book, it can be a trial to load these chambers if you do not have a plan. That is what he said, and he was certainly right. Part of the issue is these tweezers are not super awesome. I did get that position down and in. I'm just going to push it in now. Oh, okay. Here's another rookie mistake that we've made. Forgive me. We are using the wrong top pin. We need a 171 top. And our top pin, 171. Our stack height was too great for that. Just getting that rotated so it'll go down. Now we got it down. Now we're going to bring our plug follower back through, and I'm just holding it on. Okay, we've got our 3 build-up pin in. We've got our proper top pin. Hopefully you all at home are saying that's the wrong driver. Now we're going to put in our plug. We're going to try our 5 cut, and lo and behold, that works. We got our 2 cut. Lo and behold, that works. We've got our 5 cut. Lo and behold, that works. Now we can go to what they're talking about over here. because now we're going to make the 2, the 4, and the 5 work. So let us put in our 2. Oh, that's our 4. Let's put in our 2. Let's get rid of our 3 build-up pin. We got our 2 bottom pin in there because that's our change key. We're going to get rid of our 3 build-up pin. Okay. Our 3 build-up pin was, according to the book, it's 226. I'm going to put that back right where I found it. Now, I want to make a 2 work. It already does. I want to make the 4 work. You already know what that is. It's going to be a number 2 build-up pin. And according to our manual, a 2 build-up pin is 198. 198. Here you are. Now, we're going to get that 198 put in there. Okay. Now at this point, our 2 should work. Our 2 does work. Our 4 should work. Our 4 does work. Should our 5 work? Nope. It shouldn't work. What do we got to do to make the 5 work? Well, there's only one possibility. We got to add a number 1 build-up pin. And let's do that. Let's take our 4 key, let's take our, it has to be the 2 key, obviously, to pull the plug out. Let's get our 2 out. Okay, so right now we've got a 2 build-up pin. We need to make the 5 work, so that's a number 1 build-up pin because 5 minus 4 is 1. And a 1 build-up pin in 552 plug diameter is 171, which happens to be the same as our top pin. We now know that from the mistake I made earlier. 171 is over here. That's an awfully big pin. So that's all wrong. We're not using build-up pins. That was another mistake. We're now using master pins. What's number 1 master pin? It's 028. Sorry about that, folks. We're now going to add an 028 master, which is the smallest one. Okay, because we are dealing with a 028 increment. I should have known that without even looking. The issue on that's going to be getting it in place because I'm not top loading, because of how small that is. That is going to be, I'm just going to go with not possible. Let's see what we can do on that. Okay, so I've got it in place. I had it in place. Let's pause this video. So I was able to definitely get that 1 master pin inside of there. Yeah, these, and I do have spring covers. Because I'm doing 1 chamber, I didn't want to. It's obviously backfiring a little bit. I didn't want to make it more beleaguered than necessary. Okay, so our 2 key works, our two bottom, or our two, this is not our change key, but our 2 works. Ignore these symbols. Our 4 is going to work because we added a 2 build-up pin. That indeed works. Albeit, our 5, that works. And our 4, oh yeah, that works super smooth. So good. So all of our keys work. 2 bottom pin, 2 build-up pin, 1 master pin. Now, what would be the case if we had these all reversed? If we had a 5 bottom pin, a 5 change key, we would key a 5 bottom pin. If we had a, then you take the shallowest of all your masters. Let's take that 2. We're going to use a -3 because 5 minus 2 is -3 build up pin. Okay. Five, your shallowest master is a 2, so that's a -3 build up pin. Your 5 works, your 2 works. Now to make the 4 work, you add a number 2 plus 2, a 2 master pin is how that's going to work. And if we went through the same exercise, we would achieve those same results. So pinning the work is actually very simple. It's not necessarily fun when you are knowingly doing it incorrectly. The reason that I didn't want to pull this out is because I don't have my capping tool for this here, and you can even see the factory had a little damage when they capped it themselves. Okay, the factory doesn't make a capping tool for this that I'm aware of, and I didn't want to disturb that. Otherwise, you know, holding my finger on it while it works may not have been the best example of making all of that work. Okay, very nice, smooth operation on this. And that is basically the pinning. To go over that over and over again, that is certainly no problem, but that's what the manual is for. But that's the short version, is just showing it done. And, you know, you approach it, you know, the rule is this. You always pin your change key, which I use this as the change key number. Ignore these numbers. Pin your change key. Then pin your master key. If it's a higher number than your change, add a positive BUP. If it's smaller, like if it was a 1, I would use a -1 BUP. If my master was a 1, I would use a -1 BUP. That would work. Then, if I'm doing a level 3 system or beyond, pin your change key, then take the shallowest of all of your possible masters in TMK, pin to that. Then, that's either a negative or a positive BUP. Then pin to your other keys, and that should always be either nothing, no pin, or it should be a positive BUP at that point. Okay, so the combinating of it is fairly straightforward. Let's move back to the article now. Now, the purpose of explaining it this way is because I've read, you know, the other source material, and I always found it to be a bit long-winded, and I shouldn't even say that. Those who live in glass houses. But I found it to be more easily distilled by this. Plug to your, pin to your plug shear line. Just pin your change key. Okay, so you're going to drop that from the top. If you're doing a level 2 system, if the TMK cut is deeper, use a positive BUP. If you got a 2 for the change and a 5 for the master, use a 3 build-up pin. Same example, just backwards. If your TMK cut is shallower than your change, use a negative. If your change key is a 5 and your TMK is a 2, use a -3 BUP. If the TMK and your change key are the same cut in that chamber, use a 0 BUP. Add your top pins, your springs, secure your slide cover, you're done. Level 3 is going to copy the same information, except it's going to add a line. Pin to your plug shear line with your change key. Take the shallowest of all your MKs or TMK and add that BUP. If your change is a 2 and your shallowest master is a 4, use a 2 BUP. If your next master is a 5, add a 1 master wafer, which is actually what we just did. If your change key is a 2 and your shallowest MK TMK is a 1, use a -1 BUP. If your TMK is a 5, then add a 4 master wafer. You've pinned it to a 2. You've got the 1 to work. Now you need to get to the 5, and that's a 4. Okay? Or if your shallowest MK TMK is the same cut as your change key, so if your shallowest MK TMK is the same cut as your change key, use a 0 BUP and then go to the rest of the masters, which will be a positive BUP here. Pardon me, a positive master pin. Forgive me. Add your top pins and springs, secure your slide cover, and you're done. Notes on combinating. These are just my observations on how to combinate these cylinders. A little bit of a deep dive on other keys that I would exclude in my KBA. Is here. Basically, what I'm saying here is if you have a cut very shallow, okay, so if you have a combination of a very shallow change key and a very shallow master key, to where in that chamber you would create an incidental in that chamber, meaning a theoretical key could satisfy the plug shear line in 2 different arrangements, then I would avoid that. Because what happens is your pins can get cut. Let's just go through the example. If your change key cut in the first chamber is a 2, which is a 231 thousandths length in a 552 plug, and you had a buildup pin as -1, okay, and you're pinning in a ball bearing environment, you have a possibility of the pins falling below the plug shear line. So what we're saying is you already have a 116 ball bearing in there. If you have a 2 cut in your change key, you need a 115 -1 build-up pin. The issue with that is I would avoid those keys where I had that environment occurring in successive chambers. I would avoid those cut keys because I don't want to create an additional potential shear line at the plug line. At the plug level is what it is. So be mindful of your math. Don't let a cut change key combination with a deep master or vice versa create an environment where both your bottom pin and a very thin buildup pin will both fall into the plug. Okay. Service equipment and supplies. The PK1070 we've gone over. What's nice about that is it has a pinning chart, both sides, and it's here for you to review. This is actually included with the kit. This is one side. The other side, side 2, is the system that we're working on. DH Class System 70. So the book I was referring to, this is literally the same thing. I could have just been looking at the chart included. So that's very handy. You can obviously buy all the supplies that are necessary. Now I go on to talk about the use of generic or universal kits. Lab is a phenomenal company in the sense that who doesn't own their stuff? I certainly do. I've been using their EPK 3000 forever. But it would be proper etiquette for me to indicate that, first of all, it won't have all the sizes you need. If you're going to do Master Ring or IC work by Corbin Russwin, you're going to need the proper kit from Corbin Russwin. It won't have the right sizes. Plus, color-coded pins telegraph the length of the pin to the educated observer. Okay, if I know the system and I know it's a red pin and I know it's Schlage, I've only got so many choices of what that length of that pin's going to be. If I know what the length reds are, what different reds are, I think there's only 2. Plus, also the shape of the pins is not absolutely the same. This is our original Corbin Russwin. You can compare that to the Lab. It's not the same. If you want the material to work, it has to be pinned accordingly, using the right parts. And because we're top loading, if you've top loaded, then you're pinning it blind, and you utterly depend on the pins being the right length, most of all, but the right shape as well. You can see here where their tips are different. That's got everything to do with the cut class of the key blank. Okay, how that rests in the cut of the key. We can visually tell it's different. We don't even have to measure it to see it's different. Shimming open a Master Ring cylinder is not more or less difficult than a single shear line at all. Now they go on to talk about applications, advantages, disadvantages, and conclusions. Let's switch to the camera view and wrap it up there. Now, in terms of applications, where are you going to use Master Ring? Well, originally, in the history section, when you read that, Corbin literally marketed Master Ring as the technology that you would use if you wanted a master key to work your locks. If the master, and it was used to, in the word master was not used in terms of a cut key, but 100 years ago it was used differently in the book. Master of his domain sort of context. If the master of the king of his castle, let's say, or the queen, wanted a key that would pass multiple locks, and really, I think, saying assign demoted rights and privileges to others with different keys through those locks, you need to order this lock, which was the Master Ring. So, as I think about the history of lock sets, to the feeble amount that I have a grasp over it, you had lever tumbler locks with bit keys. The amount of changes in a lever tumbler lock at that time was not a huge number. I think in the Corbin books there was only maybe a few dozen changes available. So if you were a Civil War era, basically on the threshold of the Industrial Revolution magnate, maybe you were controlling railroads, okay, or a captain of industry, having 60 change keys, that's not going to work. How would that work? But then you've got the modern pin tumbler cylinder. And the way we understand it today, we can get thousands of changes out of it. And it could simply be that the grasp over single shear line and how to master key it was maybe, and this is silly to even think, but maybe it wasn't as advanced as it is today 100 years later, more than 100 years. Because the guy who invented the Master Ring cylinder, he's smarter than anyone I've ever known. But they were pushing people to Master Ring for master keyed applications. Now, it could be that if you were Rockefeller and you had tens of thousands of doors, yeah, you were going to need a cylinder format that could handle it. Empire State Building, 1932, 1933. How many doors are in the Empire State Building? I don't know. Let's agree it's a few thousand. Okay? A single shear line cylinder in a 5-pin environment, probably pretty common back then, in a 2-step system, as we went over earlier, will give you 4,096 theoretical changes. You can say to yourself, well, okay, let's say the Empire State Building had 3,000 doors. That should work. Well, if you were Rockefeller and you had offices and buildings coast to coast, that would never work. Okay? Master Ring was marketed as unlimited, the amount of changes as unlimited. Well, we know it's not unlimited. We can easily do the math. But if you had a client who needed 10,000 changes, you're going to tell the client, don't worry, it's unlimited. If you had a client that needed 50,000 changes, don't worry, it's unlimited. At what point did Corbin ever say to themselves, oh gosh, I don't know if we have to tone that down a bit because someone's going to want 200,000 individual changes? But I'm speaking in context of System 70 and 7-pin. I go back to pre-System 70 and 5-pin. They must not have been concerned over it at all because they were marketing it as unlimited. I think it was also possibly being able to market and trumpet our technology unlimited. Don't worry about it. I've got you covered. How many doors? Don't worry about it. I've got you covered. They stated in one of their old catalogs that there was a, I don't know the name of the city, but that they had Corbin Master Ring installed in every major manufacturing plant. Imagine a city like Chicago, New York, or Detroit where Corbin owned and dominated the master keyed environment. It would make me think that the Corbin Russwin of today is a small little company compared to what it was if they dominated every manufacturing plant in a major manufacturing city, which, obviously isn't accurate, but the applications are when you need a lot of changes. And you need to be able to do so in such a way where you're not contaminating the system. And as expressed in the combinating portion, bumps in the road aside, it's easy to pin. Okay, if it wasn't easily enough explained, just go over it a couple more times in the manual, or pin one and just think it through. It's pretty easy. You got to top load it though. So the question really is, its application would be for expansive projects, all the way down to homes of modest proportions. Thinking back to mid-19th century, only so many changes. Here comes Corbin. For sure, by 1905, was really full court press. Being able to say to, Mr. Executive, we've got you covered. You want to go everywhere? Here's your special key. Go everywhere. You want to have manufacturing here. You want to have accounting here. You want to have human resources here. You want to have R&D here. We've got you covered. We've got the technology that will give you that ability. I think more so giving the ability of the person to say, I can give you a key to go everywhere. And they know in their head they can build it so it's not contaminated. And I think they needed the foundation of Master Ring with its 2 shear lines to be able to aggressively go out and say, we can do it. Let's agree. They had to be aggressive in their marketing to dominate a major manufacturing city with all their hardware. They can do that all the way down to buildings of modest proportions, like the house. So the master of his domain, the king of his castle, wants to have a key that can go everywhere, but wants the maid key to get in the side door only. Great. That's it. Corbin can do it for you. Corbin can do it for you, and they can do it for you in a healthy cylinder where you don't have any incidentals. It's not going to be circumvented by the Dayton method. Lots of advantages. You know, when you have those choices, which would you prefer? Single shear line or master ring? Speaking of advantages, the most substantive advantage is that you are separating those keys to keep them isolated from each other. You're not going to run the risk of incidentals. A huge amount of theoreticals are obviously, as we've gone over, very much possible. You're not going to visually inspect the master ring shear line because you can't see it. You can't get to it. Now, what you can do, if you could take the cylinder off the door and pull the parts out and measure them, yeah, you'll be able to more easily figure out a TMK because you have less pins to figure out. Your bottom pins don't come into that calculation per se. You're measuring your build-up pins and any master pins. I understand the consensus of the general consensus of the locksmith community is that picking master ring is inherently more difficult, but by no means pick-proof, not even close. Of course, nothing is. Does take longer. A highly paracentric keyway will also enhance a cylinder's pick resistance, along with restricted blanks. All of that is available. There's an image of that H4 key blank that's there, and you can see how highly paracentric the blank is. Unlikely to be bumped. A good old bumping. That's very unlikely for it to be bumped. You've got two shear lines. You've got pins moving at each shear line. You know, how's that going to work? I've never heard of one being bumped. Unlikely to be bumped when pinned as originally designed if you're Maison keying it. Access to the huge library of P.F. Corbin, Russell Irwin, Corbin, Russell, and Emhart keying classes. 170 years worth of keys. Pick one. Not you can't get them all naturally, but there's plenty to choose from. Okay, standard and restricted. You know, if you have an X class that was in production from 1890 to 1968, you can still get mastering to that stuff. They won't do a new system in it, but you can support your system. According to Corbin Russwin, a 6-pin master key environment is equal to the capacity, similar to the capacity of a 7-pin conventional cylinder system. Again, that is a broad statement. We don't know what system it is. We don't know how we're generating. If you're getting into master keying, and you've got a great grasp of how to pin level 2, you should definitely get one book you must have, as far as I'm concerned, is going to be Fundamentals of Master Keying by Jerome Andrews. Not only is it a gorgeous book in terms of information, gorgeous, but it is written in such a way as a result of the author's ability to convey information in such a sweet and lovely fashion that you can just roll through the book. Now, it will certainly get into topics that will make you say, hold on, let's go back and start that over. But understanding TPP has to be grasped. And then Don O'Shall's book on rotating constant, and there's others. I'm not excluding anybody. That's just the one I happen to read. That's a real deep dive. You need to bring rotating constant method in when it serves the needs of the... If you're doing level 2, take a hard look at it. It's probably going to work. And I'm not an expert in any of that, but I have exposed myself enough to appreciate when and where you're probably going to want to take a look at using it. Inherently less prone at the plug shear line. In most cases, fully insulated to exposure to ghost keys and implementing a rotating constant method when it serves the requirements reinforces all of the advantages mentioned prior. commercially available and an adequate diversity of hardware items makes a dependable deployment of hardware on the project assured. You're going to be able to make that all happen. Coupled with the current demand from the marketplace for lots of options, finishes, Corbin Russwin can deliver. They can give you the Master Ring, and they can give it to you in almost every every mortise lock that you might need. Not every. You'll want to fully study the book to make sure that you can get what you need in mastering if you decide to go there. I have spoken to Key Records. I've spoken to technical support. They are not rolling out a lot of new mastering systems. There's just no doubt. They're not. But they are mastering. No one else is, and they have to support that. Another advantage, Corbin Russwin, those names are ubiquitous, universally familiar to industry professionals, tried, true, and trusted. Some disadvantages, watch out for functions not being available in your mortise locks. And you are going to find, if you study the greater deployment of possible hardware options, as maybe limited. No grade 1 lever, no grade 1 knob. Your exit devices are very limited. Okay, so you have to decide that. Unless you want mortise locks everywhere and you're flexible with the exit device, you might need to immediately go away from mastering. But if you're great with mortise locks everywhere and you don't have a need for some of these esoteric functions, you're in good shape. If you don't have a need for some of the electrification over your exit devices, like electric cylinder dogging, you're in good shape. You can put electric cylinder dogging on a fire-rated device because that's connected back to the fire panel. Will undog your device. Another disadvantage could be a general lack of knowledge of the Master Ring platform, the science behind it, the ways to exploit the platform to achieve the results that you're looking for. It's uncommon, and a lot of locksmiths, and I'm coming from disadvantage from being able to find somebody that can competently work on it. I've read stories, I've heard stories where someone got a Master Ring cylinder and they had no idea what they pinned because, it was cross-keyed at the plug, or they single keyed it and had stacked pins to make the epic 421 thousandths length driver. So none of that's really good. So a general lack of knowledge. The problem is the general lack of knowledge does bleed into the manufacturer's responsibility or culpability as well. I've called there a couple of times, and there is a, we don't see that often sort of response. So there is an erosion of talent at the factory to talk about it. Not that they don't have the talent, they do. But here's the bottom line, what I'm trying to say. When you're Corbin Russwin and you are not actively deploying Master Ring all the time, the requirements to work on it, to have people on staff to understand it and to work on it, obviously are not as intense either. Asa Abloy, certainly, who owns Corbin Russwin, Sargent, Yale, Norton, Rockwood, Adams Wright, McKinney, Pemco, Hess, a million other things, I'm sure. They certainly do have the talent, there's no question. You got to have a pin kit to do it. That could be a disadvantage. Your lab EPK 003 is not going to work. The list price on that, the 2019 list on the PK 1070 is $938. I have read that deriving a TMK and MK through physical disassembly is easier. I would agree that it is. That may be a disadvantage, but I would call it an advantage. Deploying a Master Ring system would, when it comes to just deploying it, is going to prevent you from using other people's mortise lock bodies. In today's world, we're doing Yale locks, but I got to have my Schlage keying system. You will not be throwing a best system into, you will not be throwing a Master Ring key system into anyone else's lock chassis except Corbin Russwin's. That may be a disadvantage. Another disadvantage could be, is certainly that there are no high security. There is no UL 437 as an option. Okay. And if you're doing level 1 keying, just change keys, I see no advantage in Master Ring at all. Why would you spend extra money for it? it shouldn't even, I would think, come up on your radar if you're not going to key it like that. Key it as its inherent advantages. So in conclusion, in this video, a la the article, I've sung the praises, hopefully, of the Master Ring platform. I do admire the format, its capabilities, and its 120 plus years of heritage. I do believe it is a simple and elegant platform. However, my admiration may just be the twinkle in my eye for those special products in our industry, those that we enjoy working on, talking about, but may not be around forever. To make that point even clearer, at the annual Aloha convention in 2019, I interrupted a very well-known person, an industry organizer, pillar in locksmithing, and said, "Hey, may I have your, would you please review my key bitting array? I'm doing a paper on Master Ring." He's like, "Master Ring? Why are you even writing about that? They don't even make those anymore." And while they certainly do make Master Ring, his point illustrates, what he said illustrates the point. Who's talking about Master Ring? No one. Almost no one. But I am. And I am just from the perspective of saying, hey, this is a really great piece of technology. You're probably not going to use it, but let's talk about why it was used and dominated the Empire State Building. Okay? If you're putting Corbin Master Ring into the Empire State Building, they were probably putting the best in that building. Now, I don't know anything about it, but that building was a... all spotlights were on that building during construction. If you know anything about the building of it, it was an epic effort that came in under budget and before schedule, before deadline. And that tells me that Corbin Russwin certainly had their act together, delivering stuff sooner than it had to be on the job by a normal construction schedule. But what the gentleman said was, why are we even talking about it? It's a piece of locksmithing history, a big piece of it. And the information available is Corbin Russwin Manual has good stuff on it. GL Jerry Finch has good stuff on it. Robert Sivking has good stuff on it. Mark Tobias has a small blurb on it. And this paper, I kind of wanted to put all of that together, albeit very long-winded, but nonetheless. Okay, so what is the conclusion for the Master Ring? The likely conclusion is that in 10 or 20 years from now, when they've spent a couple of decades not populating new systems, it'll probably be sunsetted, it would be what I would imagine. But it is reassuring, thinking about sunsetting the technology, to think back on how great of a job they must have done for so many decades. You know, mid-century installations in major metropolitan areas. I spoke to a Detroit locksmith not too very long ago who said, yeah, all the mansions in that part of Detroit from that, you know, roaring 20s sort of era, that's all Master Ring there. All those mansions. And once in a while they come in and we got to rekey that stuff. So it's definitely out there. And, you know, I would say this is very likely that same era. These cylinders just last. They're a hunk of brass. Speaking of a hunk of brass, because we're at the end of this video, have you ever seen a 3-inch long cylinder? You may have. I have. I've ordered them. I've made them. Have you ever seen a 3-inch long Master Ring cylinder? Okay. That's pretty epic. That is a lot of cylinder. Okay. That's one thick door you got there, buddy. Anyway. So I would like for us to remember the Master Ring cylinder, should it ever go away, for the capable job that it did for so many decades. We understand, we've decoded the science behind how it could do its job. It's basically simple. So many chambers, okay, 2 KBAs, you're segregating, you're separating them, you're going to hit lots of change keys possibilities. The issue, though, is that there's no reason the Master Rings stay around. And that brutal statement is because another sister company that I haven't mentioned, I just forgot, Medico, and their Medico 3, they have a single shear line cylinder. Well, it's not a single shear line, but they have a mortise cylinder that total key control, patented key blanks, very pick resistant, UL 437. UL 437 is basically a document that says try to pick it, try to impression it, try to break it, try to wrench it, try to flame throw it, okay, for so many minutes. And if it survives, it's UL 437. And with that Medico 3 cylinder, they can give you 1,000,000 actual change keys. So where does the Master Ring fall into play? When their sister company, is the problem change keys? Medico can give you 1,000,000 of them. Sergeant Kesso, another sister company, they can give you several million. And in that system, you can't buy the key blanks, you can't duplicate keys, you can't buy the machine to duplicate the keys. No one can, because they don't sell that stuff to the public. It's all done at the factory. So there just may not, for these obtuse applications where huge numbers of keys are required, huge control over the materials for the key system is required. Let's say you're Lockheed Martin. Yeah, you're going to have some special keys, okay? R&D at Sandia National Lab, Area 51, I don't know. These places have actual requirements for physical key security. Master Ring can't supply that because it can't give that. And those companies already exist. And they nail it. They kill it. Speaking of Medico, I was incredibly fortunate enough to be sitting in a class, the one that I mentioned earlier, and I don't know if he's the head of research and development, but Peter Field of Medico. I sat with him for 10-15 minutes and talked about my key binding array. It was just, it was amazing to be able to sit down with such a soft-spoken, brilliant individual and have him looking at your work. And just being able to appreciate the knowledge of every single word that he said. You could tell that there's an incredible level of mastery of the subject matter at hand. So, what could Master Ring do to hang on? You might get some patented keyways that are exclusive to Master Ring. You might try to find a UL 437. You might do security leg keyways. Best has had those. I was told that they're not really that popular because they're difficult to use. People can't get the key in the cylinder easily. Sidebars. Medico can teach them about sidebars. Maybe a super Master Ring, maybe a 3 shear line Master Ring. Who knows? That would be kind of cool. Higher caliber pins, set screws rather than a slide bar. If I were to push a Comatach in here and force those up, I'm going to burst that. But drilled and tapped set screws, I'm not going to force those out. Medico does that. Maybe a curtain in the cylinder plug, that might work. Now, actually, to finish this video completely, there are reference documents, books that I've referred to in studying for this article. They're all listed. The ones that I have with me are here. The people that I've spoken to are also listed here below. There is, as an aside, when I was studying for my certified registered locksmith exam, The Lure of the Lock is a book that came up. This is an original, and its copyright date is 1928. 1928. Okay. A short treatise treaty on locks to elucidate the John M. Mossman collection of locks in the Museum of the General Society of Mechanics and Tradesmen in the city of New York, including some of the Mossman papers with 500 illustrations. John Mossman was a lock, I think he was a outside traveling lock salesman who focused on locks for bank vaults, safes and vaults. Turns out Mr. Mossman, in a 20-year period, built himself one hell of a collection. And that collection, as I'm reading the book, studying for the CRL test, I get part of the way through the book and I realize, okay, this is variations on a theme. They are giving you a forensic level inspection of all of this technology that is solidly 18th century, 19th century technology, enough to understand the big parts of the locks, of the different types of locks, so that when I took the test, if these questions come up, I would be reasonably capable of getting it right. But as I study this Mossman collection, I come to realize the General Society of Mechanics and Tradesmen of the city of New York, that place exists. And not only does the place exist, but the locks exist. These locks are there. Well, coincidentally, over the 4th of July in 2019, I was going to New York to be a tourist. My son, my godson. Well, I called the General Society about a month before, and I said, I'm going to be in New York on July 3rd. Or July 5th, whatever day it was. Can I come? Yeah, I think so. I think we're going to be closed, though. You know, we don't have a lot going on. And I says, okay, well, I certainly understand if you're going to be closed. Here's why I'd like to come see it. I'm studying for the Certified Registered Locksmith exam. I have fallen in love with locksmithing. You can't believe the amazement when I realized that these locks not only existed in history, but they exist in the current day, and I can pay, and I could cover the suggested donation and go in and view all of it. And they said, wow, you really appreciate the lock collection. They said, you know what? You call a day or two before, and we're going to have somebody here to let you in. I says, what museum does that? That's really amazing. Sure enough, I called. They said, well, absolutely. I remember you calling. You're going to get here, and you're going to ask for so-and-so. I won't give the name. I show up. I ask for Mrs. Not so-and-so, but Mrs. And the security guard has me wait a moment. I go okay to go upstairs. I go upstairs, and goodness gracious, but the curator of the collection is there, who has personal ties to the society. And I was just floored. You know, the kindness of this person. I spent an hour viewing the collection. I would have taken 3 hours, but they were there working, but I didn't want them to have to be there for me, so I gave myself 60 minutes. Took some pictures, which are linked to down below, the locks that I really like. The Brahma lock. Oh, you can buy a Brahma lock today. If you study locksmithing, Brahma features a radial key design. I bought a Brahma mortise and a Brahma rim. And I'm going to build I've done it in the past, a Seagull, like a 687. I'm going to build myself a Seagull lock with Brahma cylinders, just for the sake of doing it. I've done it in the past with an odd mortise cylinder on the interior. So they have original Brahma cylinders in the collection. The suggested donation is $10 a person. I certainly could not fathom a donation of $10 when these folks are opening up the museum just for you. And I really encourage you to visit and to donate greater than the suggested donation, if not for the collection itself, but for the kindness of the staff. It was a really great capstone of not only culminating the CRL studying for the test, but the kindness of the people combined with the subject matter really came together. It's like when you go to a Civil War battlefield, if you're into Civil War battlefields, and you really get a tour guide who says, you know, I live and breathe this stuff. And then it really makes the experience better for you, and that's what those folks did. So, reference documents to people I've spoken to. Then there's a list of Corbin Russwin trade magazines that are here. Articles, not articles, just advertisements, maybe a dozen of them that I found available. And then there's abbreviations and then definitions down below. Okay. So please do forgive some of the bumps in the road previously. The entire afternoon has been time constrained, so here we are. And their tagline, Corbin, you'll find it, good buildings deserve good hardware. Good buildings deserve good hardware, and I feel that Corbin does it. So if you have any questions on the Master Ring, hurry up and ask before I forget everything I've learned about it. My name is Rich Howard, owner of Architectural Builder Supply. Thank you very much.